Hi everyone, this is Babaiah, Assistant Professor of ECE Department, MLR Hyderabad. Now I am going to explain the special cases or solve the some problems on special cases of RH criterion method. In previous session, we learned how to divide the special cases from the given characteristic polynomial equation and all how to arrange the array matrix. All these learned from the previous session. But today, now we are going to learn the some problems on special cases of RH criterion method. Next, move on to the first overview of first case here. See, observe the first element of row is 0. If the first element of row is 0, in that condition, we are going to solve the one problem by using the RH criterion method. Here, this one, the question for. Next case comes here, a row of all zeros. These two are the two special cases. And next here, special cases, and that we see the first case here. First element of a row is 0. First row or first element of any row or at least one row is 0. In that condition, we are going to use the two methods. One is consider the in place of s substitute the 1 by z, and or else another method is just we are going to use the in place of 0 we consider as a small value, small positive value of epsilon we consider. These two methods we are going to use when we are going to get the first element of a row is 0. First method is just to consider the in place of 0 we are going to consider the small positive value is epsilon. That is the first case or first method. And the second method in first element of a row is substitute s equals to 1 by z. These two methods we are going to use to solve the any problems based on the first element of a row is 0. See, come now I am going to arrange the array matrix and how to solve the special cases. Now we are going to see here array matrix. See here, observe, construct the row array and determine the stability of the system represented by the characteristic equation is this one. So s power of 5, s power plus s power of 4 plus 2s cube plus and plus 3s plus 5 equals to 0. Okay. Next, comment on the location of the roots of characteristic equation. See, what is the maximum power of the characteristic equation is what? 5, right? So maximum power is 5. So how many roots? Order equals to 5. So that is equals to 5 roots. Order is nothing but the roots here. From the characteristic equation, maximum power of s is nothing but the roots of that characteristic equation simply. Now we have a 5 roots are available from the given question, right? So now I am going to draw the array matrix or arrange the array matrix s power of 5, s power of 4 and s cube and s square, s power of 1, s power of 0 up to s power of 0. See, first two rows are arranged from here from the question. S power of 5. 5 is odd number, right? So s power of 5, odd number coefficients of s. See, observe. First odd number coefficient is what? S power of 5 is 1. Next s power of 3 is odd number. So coefficient is 2. And s power of 1 coefficient is what? 3. This is the first row elements. Means s power of 5 row elements are arranged from the given question. Like that we are going to arrange. Next, see the s power of 4. 4 is nothing but what? Even number. So even powers of s. See, observe. S power of 4 is coefficient is 1 and s power of 0 also even, right? S power of 0 coefficient is 3. Any more or there? Oh, sorry. S power of 0 is s power of 2 is 2 and s power of 0 is 5. See, s power of 4, s power of 2, s power of 0 is 5. These are the two rows, s power of 5 row and s power of 4th row. Now we are going to calculate the s cube row elements. For that, this one is our base, right? This is our base. So this one is base and multiply this 1, multiply with the 2, again 1 multiply with the 2. 1 multiply with the 2 minus 1 by 2 divided by 1. Here 1 multiply with 2 minus 1 multiply with 2, base is 1. So what is the value here? 2 minus 2. So 1 into 2 minus 1 into 2, 2 minus 2 is 0. So first element of S cube row is 0, right? Next see 1, 3. 1 into 3, 3 minus 1 into 5, 5 divided by 1. What is the value? Minus 2. 3 minus 5 is nothing but minus 2. So here minus 2. Next see, observe. For this element, just remove these two values. 1 multiply with the 3 minus 1 multiply with the 5 divided by base is 1. You will get this element. Next, this element for next row element, next elements. There is no element, so consider as 0. So here see, first element is 0, right? It is comes under the one special case of RH criterion method. First element of a row is 0, right? S cube row first element is 0. In place of, we are going to use the two methods. One method is consider the epsilon in place of 0. So we are going to see that method here. Now just again I am going to draw. Why we are going to consider the in place of 0? Epsilon means, see here from the next element, S square elements are 0 multiply with 2 minus 1 minus of 2. So 0 minus or 0 plus 2 divided by 0. So 0 is our base. Some value divided by 0, value divided by 0, value divided by 0, nothing but infinite, 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 infinite series of numbers. So we can't find the exact values also. So infinite numbers are there, infinite values occur. So that's why we are going to consider in place of 0, consider as small positive value as epsilon. Okay, now again I am going to draw this one. Okay, s power of 5, s power of 5 and s power of 4, or otherwise here I am going to draw in next page. S power of 5, s power of 4, s cube, s square, s power of 1, s power of 0. See question, s power of 5 elements are what? 1, 2, 3. 1, 2 and 3. S power of 4 coefficient 1, 2, 5. 1, 2, 5. Next s cube. S cube we got the 0, right? First element. In place of 0 we are going to assume the small positive value is epsilon. Small positive value is epsilon. So here consider epsilon. Next value is minus 2. See here minus 2. This value, last final value is 0. So here first element of 0 consider as epsilon. See now next elements of s square row elements, epsilon multiply with the 2 and 1 multiply with the minus 2 divided by the epsilon. Epsilon is our base now. So 2 epsilon minus of minus plus 2 divided by epsilon. So value is what? 2 epsilon plus 2 divided by epsilon. And next here this value for the consider of our calculation of next value, next coefficient is epsilon multiply with the 5. 5 epsilon minus 1 into 0, 0 divided by epsilon. So value is 5. Okay. So next elements are, there is a no value, so consider as 0. See here next to these two, 2 epsilon plus 2 divided by epsilon multiply with the minus 2. 2 epsilon plus 2 multiply with the minus 2 divided by epsilon minus 5 epsilon divided by 2 epsilon plus 2 divided by epsilon. So here here consider, here epsilon is common, so here value is what? Expand this one, minus 2 minus 2 epsilon minus 2 minus 5 epsilon which this value multiply with the minus 2 plus minus 4 minus 4 minus 4 1 second, this is epsilon minus 4 minus 4 2 epsilon plus divided by epsilon plus 2 divided by epsilon multiply with the minus 2, complete value minus 5 epsilon divided by this term. So here 5 epsilon square, here epsilon 2 epsilon plus 2 by epsilon both cancel. So minus 4 epsilon minus 4 minus 5 epsilon square. Just write the value here, minus 5 epsilon square minus 4 epsilon minus 4 divided by 2 epsilon plus 2. Next value is this value 0. Next here see, s power of 0, this value multiply with this one and this value multiply with this one divided by this, these two are get cancel. So value is what, 5. So s power of 0 coefficient is what, 5. So you will get the 5 directly, or else just to solve this method also you will get 5 only. Okay, now see 1 epsilon 2 epsilon plus 2 divided by epsilon, all these in form of epsilon value. But for the estimation of a given system stability condition, we are going to consider as, or let assume let epsilon tends to 0, substitute limit epsilon tends to 0, in place of epsilon we are going to substitute the 0 for the estimation of the system is stable or unstable, or how many roots are lying on the left side or right side of the S-plane. For that we are going to consider or substitute the 0 in place of epsilon. See here, 0 in place of epsilon, see s power of 5 1 2 3 and s power of 4 1 2 5 and s power of 3, here epsilon plus 0 minus 2 and 0 s square, epsilon in place of 0 multiply with 2 0, so 2 divided by 0, some value divided by 0 is what, infinity, here 5 and 0. Next here 0, this value 0 minus 4 divided by this value 0 2, so minus 2 and 0 0, last value is 5, s power of 1 s power of 0. See, observe here value is what, infinity, so here negative value minus 2. So how many roots are changed? This s power of 5 is positive coefficient. Observe the first column elements, first column elements, first column elements. Is there any sign changes are there? The sign changes are nothing but the roots lying on the right half of the S-plane. See here, this one is positive, these elements also positive, plus 1, 0 also positive, infinity also positive, here minus 2 is negative. So from positive to negative, positive sign to negative sign, one root change. Next minus 2, this value is positive 5, so from here to here second time change. So how many roots are changed? Two roots. Two roots are changed. So two roots are lying on the right half of the S plane. Right half of the S plane. Total how many roots? The maximum power is 5. So 5 roots. Out of 5 roots, 2 roots are right half of the S plane. Remaining 3 roots are left half of the S plane. So then the system is unstable system. Why unstable system? At least one root is lying on the right half of the S plane, then the system is definitely unstable system. All the system roots, all the roots of the characteristic equation or polynomial equation must be lying on the left half of the S plane. Then only we say the given system is stable system. Otherwise, at least one pole or one root present on the right half of the S plane, then the system is unstable system. See here, how many sign changes are there? Total 2 sign changes there. So 2 sign changes are there is nothing but what? 2 roots on right half of the S plane and remaining 3 roots on left half of the S plane. Then the system is unstable system. Unstable system. Next here, sim. This is the one more method. See, one another method is second method. For the second method means here substitute S equals to 1 by Z from the given or given in a equation or in characteristic equation. S power of 5. See question. S power of 5 plus S power of 4. So S power of 5 1 by Z power of 5. Otherwise, first write the question here. S power of 5 plus S power of 4 plus 3S square plus S cube S square plus S plus 5. So here values, coefficients are 2, 2, 3. 2, 2 and 3, that is equals to 0. Substitute S equals to 1 by Z. This is one method. In previous method is what? Consider the epsilon small positive value in place of 0. Okay. Next see here, substitute S equals to 1 by Z. 1 by Z all to the power of 5 plus 1 by Z all to the power of 4 plus 2. 1 by Z all to the power of 3 plus 2. 1 by Z to the power of 2 plus 3. 1 by Z plus 5, that is equals to 0. That is equals to 0. See here, take the LCM. 1 by Z power of 5 plus Z power of 4 plus 2 by Z power of 3 plus 2 divided by Z square plus 3 by Z plus 5, that is equals to 0. Now see, LCM Z power of 5. So here already 1 is there. So 1 plus Z power of 4 is there. 1 more Z. So Z plus 2 Z power of Z cube. So 2 multiply with Z square plus 2 Z cube. Already 2 is there. So remaining 3 just write. Here only 1 there. So 4 required. Plus 5 is there, no one. So Z power of 5, that is equals to 0. See here, final equation is what in terms of Z? 5Z power of 5 plus 3Z power of 4 plus 2Z cube plus 2Z square plus Z plus 1, that is equals to 0. Now we are going to arrange the array matrix for the characteristic equation in terms of Z. Now see here, Z power of 5. See, maximum power is 5, right? So Z power of 5, 4, 3, 2, 1, 0. See, Z power of 5, odd number. Odd number coefficients 5 and 2 and 1. 5 to 1. 5 to 1. Z power of 4, even. 3, 2 and 1. Sorry. 3 to 1. Z cube, just these two multiplied. This is our base. Same procedure, previous. 3 multiplied with 2. What is the value? 6 minus 5 into 2. 10 divided by what? 3. So what is the value? Minus 4 divided by 3. Minus 4 divided by 3. Next 3 into 1. 3 minus 5 into 1. 5 divided by 3. So minus 2 divided by 3. Minus 2 divided by 3. Next two values 3. Next these two values remaining is not there. So that's why directly write the 0. Next Z square of coefficients are minus 4 by 3 multiply with the minus 2. Minus 4 by 3 multiply with 2 minus 3 multiply with minus 2 by 3. So 3 both cancel. So here what is the value here? Minus 8 minus 6 minus plus 6 divided by 3. So value is minus 2 by 3. Minus 2 by 3. Minus 2 by 3. Next value is, just observe, these two multiply with minus 4 by 3, 1, minus 4 by 3, and this value is 0. So minus 4 by 3 divided by minus 4 by 3. So value is 1. So 1 minus 4 by 3. Sorry, here 1. Next here this value is 0 directly, because of there is a no element. So minus 2 by 3 multiply with the minus 2 by 3. So what is the value? Minus 2 by 3 minus 2 by 3 multiply with minus 2 by 3 minus of 4 by 3 divided by minus 2 by 3. See here, minus 2 plus 4 by 9. 4 by 9 minus 4 by 3 minus 2 by 3. So here take the LCM here. See, 9 4 minus 12 divided by 9 divided by minus 2 by 3. Minus 4 minus 4 minus 12 minus 8 divided by 9 by minus 2 by 3. 3 minus plus 16 by 3. So 16 by 3 positive. This value 0 and this value 0, again 0, so 0. Next this value 16 by 3 minus 2 by 3. 16 minus 2 is what? 14. 16 minus 16 by 3 minus 2 by this value minus 0 only, right? 0. So 16 by 3 only divided by 16 by 3. So value equals to 1. So 1. So what is the value here? See, observe, from positive, this value is positive, here also positive sign, so here negative. So from here to here how many changes? One sign change. Next negative to negative, no sign change. from negative to positive. Here this one is the negative sign, here positive sign. So negative to positive, two sign change, positive to positive. So how many sign changes are there? Two sign changes are there in first column element. First column elements, just observe all these first column elements. Two sign changes are there. So the two roots are on right half of the S plane. Then remaining through three roots on left half of the S plane. Then the system is unstable. Unstable system. See, same two procedure also we get the same answer. Two sign changes. So two roots, right half of this plane. Remaining three roots, left half of this plane. We are need to follow the two procedures also for the first case or first element of a row is 0. That is the special case of RH criterion method. We need to follow these procedure to solve the RH criterion method problems like special cases. That is the first special case is here. First element of a row is 0. I hope you understand. First what we do, take the characteristic equation, from that arrange the array matrix. What is the order of that given characteristic equation? That order is nothing but the roots of that characteristic equation. Now we after that arrange that array matrix, we are going to solve the all row elements. If any row first element is 0, we are going to just consider in place of 0 the small positive value is epsilon. Then we need to continue the next procedure up to end the s power of 0 row elements. After that we are going to estimate the given system is stable system or unstable system, estimate the poles or poles location on the S plane. For that we are going to consider or substitute in place of epsilon 0. We need to substitute the 0 in place of epsilon. By that we are going to get the 1 1 0 infinity minus 2 5, positive to negative, negative to positive, two sign changes. So there is a two sign changes are there. So that is nothing but the two roots lying on the right half of the S plane. Then the remaining three roots on the left half of the S plane. Then the system is the unstable system. That is the procedure. And one more procedure is what in place of S we need to substitute the 1 by Z. So directly substitute 1 by Z and solve, take the LCM, and finally we are going to get the characteristic equation in terms of Z. After that we are going to arrange the array matrix and we need to follow the same procedure. Then we will get we are going to observe the first column element of the array matrix. If there any sign changes are there, the sign changes are there nothing but the roots on the left or right half of the S plane. If the sign changes are not there, all the roots on the left half of the S plane, we say that given system is estimated. And so the system is unstable system. If at least one root available on the right half of the S plane, then the system is unstable system. I hope you understand. This is the procedure to solve the problem of special cases. Thank you all.